Yeah, I am in zero trust and identity, or like at least for us when we do a lot of government work, like that's like one of the hottest things, and doing AI on it is like I don't know. I recommend talking about it after. Like for us, that's we've seen a lot of interest here. I want to introduce our next speaker here. I want to make sure as part of the representation of speakers today, kind of like how we had Josh from the Llama 3 purple teaming team. I want to have somebody more on the side of actually doing some of the more kind of like, honestly, like hardcore LLM stuff in terms of, you know, if you think about autonomous agents, autonomous hunting, something like, can you do multi-steps and sequences of these agents at the model level? When it does make one of those steps, is it actually doing the right function call? And so it's actually one of the kind of rising stars at Berkeley. It's kind of an honor to have Jiantao. Am I pronouncing that right?
Yes.
Yeah, so Jiantao here. So that I'll let you take over.
Thank you so much, Leo. Really excited to be here, everyone. So my name is Jiao. I'm a CEO of NexusFlow. We founded the company last year. Our focus on building enterprise-grade GenAI software agents. Today, I'll be going over the technology and also the vision. It's very slow. Okay. So what do I mean by GenAI agents? So in the company, we focus on the tasks that require interactive decision-making with natural language queries, in particular when the task is complex. Here's one example in the consumer setting, but you can also think about similar examples in the enterprise case. For example, you talk to a dashboard, you have to take actions, conducting search. You may be asking a question, I want to go to concert hall in San Francisco, I visited last time, and pick up my son along the way. And agents not only can talk to you, agent also has access to all the tools available in your systems. In terms of enterprise use cases, maybe the APIs and dashboards. And it's able to answer the question, produce the final summary. But so what's really happening under the hood should be really this complex function call. So basically, without explicitly interacting with agent round by round, the agent's supposed to come up with this plan. We call it micro plan to get location, get ID, get last visited places, put everything together into the navigation function so that you can just get the final results. For this, we call it complex instruction following and tool use in a safe and helpful way. By safe helpful, it also refers to the answering style of the agents. So why we want to start the company was that last year we started interacting with lots of enterprise customers. At that time, they were starting to build their agents using GPT-4. In particular, when they saw that they had to use GPT-4 because only GPT-4 has the reasoning capability to actually conduct those kind of tasks. They came to us, they felt that even with GPT-4, they cannot get a sufficient success rate for these complex use cases. So these are very good engineers who try to decompose the problem, solve the problem step by step. Then they found that, first of all, has incurred a very, very large latency. 30 seconds is even a lower bound, easily goes to 1 minute. Sometimes, extreme case, customer told us that it takes them 10 minutes to finish one query and final result is still wrong. So basically, while it's the design principle that if you fail, you fail fast. So it's a disaster. And another key issue they found is the hallucination. So basically, you give GPT-4 a set of tools. You say, well, those are the APIs in my dashboard. Then please answer the query. But GPT-4 sometimes will think that there's another tool and has seen the training data that answer the query better. Just call that tool didn't exist in your system. The system will just break. So basically, to build everything into production, we need very accurate comprehension, very high success rates, minimal hallucination, high reliability, and also very minimal latency. So how did we really solve the problem? At that time, we don't even have GPT-4. Actually, we don't even have Llama 3. We only have Llama 2 at that time, which is actually significantly worse than GPT-4, both in terms of coding and also like the creative content generation. So one observation we made at very early days is that, especially for smaller models, there appears to be a trade-off between two reasoning capabilities. One we call extractive reasoning, which refers to the reliable synthesis of intentions. For example, I asked my Gen agents, I want to navigate to San Francisco Symphony and pick up my son. I don't really need the model to hallucinate and create lots of fancy stuff. It's just supposed to faithfully execute my plan. But there will also be other use cases. For example, I indeed need a large language model to hallucinate. For example, let me please write a poem. Then, in particular, the poem has never been seen maybe in the training set. The model really is supposed to write it. So basically, GPT-4 is in a dilemma because in settings where we want it to really only read our documentation, we do not want it to hallucinate. In settings where we want it to hallucinate, it really needs to hallucinate really well. It really appears that even for GPT-4 size, the model finds it difficult. It cannot faithfully execute the instructions. So what we did is that we have separated these two capabilities. So we trained a model called Next-Driven V213B, which is open source model you can actually download. Really excelled at extract reasoning. Actually, in the benchmark we have built, focusing enterprise complex tool use cases. In particular, we use the real technical software from the cybersecurity industry to show that the model, without seeing the software at all, is surpassing GPT-4 in these complex use cases. It's very strong in exact reasoning, but in abstract reasoning, we have built another model called Starling 7B. Actually, before Llama 3 came, Llama 3 is also 8B, not exactly 7B. Till today, it's still the best 7B chat model in the most recognized human email leaderboard, chatbot arena, surpassing lots of models of significantly larger sizes. For example, even Llama 270B, and roughly on par with Mixtral 8 and 7B, and better than Gemini Pro, and also a few versions of GPT 2.5. So in today's discussion, I'll be going over some technical details of these models. So basically, two models I want to go over in today's discussion. One is this Raven model, focusing on complex software tool use. Second one is the Starling model, which we trained to really enhance human preference. That's the reason why in chatbot arena, for those of you who are not familiar with chatbot arena, the way it works is that a user can submit a query, and then Arena will present you with two responses from two anonymous models. And you will pick which one answered better. So we don't really know which model was picked. Seems that we have gone offline. Okay. Okay, sorry about that. So we will talk about how we really boost the human preference. So first of all, on this two-use model, so what exactly do we mean by two use? There are many settings of two uses. Actually, these are also not exhaustive. The simple case might be single to API. Here's extremely simple example. I want to recommend some concerts. You get a function called get recommendation. Very simple. You ask any model, essentially in the world, they can all do it. So this use as benchmark is not actually very, very meaningful. Parallel to use cases is also very important. For example, you want to recommend both concert and museum. I'm supposed to call two functions in parallel and also execute them in parallel. So that it's very efficient. And the hardest one is the nested tools. Actually, for that, you should view this as generating a micro plan, because you have many tools in your environment. You're supposed to compose the tools together and form a plan. That also is consistent with our general thesis, which is that we really think of human tool use. We use tools not really because we have like 1 billion tools in our repository. It's really because we have a few, but we human beings are very smart. We know how to compose them together. So the model needs to really figure out how to really come up with the plan. We curate this benchmark for zero-shot tool use, exhibiting 7% high accuracy for the hard cases for parallel and nested function calls than GPT-4. With a significant model, smaller model size, it's only 13 billion parameters. So the main rationale behind this is that we start from code Llama 13B, which is actually not quite usable for this task. If you ask even simple questions for tool use, cannot really answer. We added very large scale instruction tuning data to tune for tool use reliability, and it was able to surpass GPT-4 for these complex cases. Actually, for simple cases, it's not really surpassing GPT-4. Because simple cases actually GPT-4 is very good, and we are actually didn't really focus on in that case. So this plot to us is also quite interesting because Llama itself, abstract reasoning is way worse than GPT-4, and even after our tuning, it's still way worse. But we don't really care about this because our focus is on this extractive reasoning. For that, this model is very better to be used as an intermediate component for your agent systems. This generally consists of many components, not only a single model. So this some details about this benchmark. We have collected many different technical software. So there's VirusTotal, VT. There's also this NVD library. Those are actually very challenging softwares. In particular, easily has 20 different arguments. You ask any model in the world, it just cannot answer the question. So turns out it's for this challenging technical softwares, we perform really well. So that through building the benchmark, we also learned that we really need to create the benchmarks such that it can easily differentiate different models. If all the models are behaving similarly, it means maybe the benchmark is meaningless. So these are very challenging cases. The benchmark is open source, so feel free to check it out and give us some feedback. So after the model was published, we were very excited to see that there's actually another third-party evaluation of the model. Actually also compare the model with GPT 3.5 and GPT 4. It's quite interesting evaluation because it exactly tackles one key issue in tool use, which is that suppose you give the model a set of tools, ask model to accomplish a task. Did the model really read your documentation, or the model was basically using its training data to guess what these tools are for? In that case, it's going to be really problematic because maybe your tools are actually different from the tools the model has seen in the training data. So in this paper, what they did is that they created a set of tools, but they perturbed the tool names and those argument names. So basically, if you follow the tool descriptions of the tools in your training data, you would have made a mistake because I've actually changed the tool name, mapped to another tool, and changed the argument names. So it's just in this data set, our performance is significantly better than GPT-4, GPT 3.5, achieved zero hallucinations because GPT-4 can just hallucinate a tool that didn't actually exist in the system. Of course, the GPT 3.5 would hallucinate even more. And if you think in terms of accuracies, even for the single function calls, actually I mentioned for single function calls, our performance in general is not as good as GPT-4. But this is a very hard case because we have distorted function names. In this case, GPT-4 will degrade because it was hallucinating based on its training data. It actually appears that we do not really hallucinate because we have dumped in so much high quality training data in the model. So the model really follows the instruction very well. So after we release the model gets very exciting feedback from the community. It's the highest downloaded model on function calling. The support from Meta, the shout outs, and also from peer startups, also from developers. Quite a few people are saying that they have completely kicked out the OpenAI function calling API and used our model to serve their whole business. How much time did I have? So maybe one more thing I want to talk about is this starting model on this RHA pipeline. So starting focus on different capability, which is chat capability. Basically, it really wants to make sure, given the same set of technical capabilities, I chat with you, you just feel it's very helpful and very harmless. So we train the model, we put the model on Chat Arena. It appears to be very competitive compared to those very large ones. Till today is still the best one for 7B size, if you do not consider Llama 3 8B. And the key idea behind this will be some new RCF algorithms we have developed. Actually, some papers are already published. Some others are still under review. It's a new approach. So that's basically what I want to show. Thank you.
I don't know. Sorry. We have time for a couple of questions while our next speaker sets up. Yeah, we've got a.
I have a probably dumb question. I don't know the answer to it, but I think I like your kind of philosophy of having this continuum of sort of abstract and more expressive. I was wondering, have you tried something like trying to control where GPT-4 sits on that continuum just by telling it don't hallucinate or hallucinate wildly or something like that? And could you just imagine one model that you could just control where it sits on that rather than trying to train two separate models?
Yeah, this is a very, very, very good question. So actually, we're still trying to pursue that direction. At least for GPT-4 itself, we found that in these very challenging cases, we tell GPT-4 so explicitly, please do not do that. It cannot follow instruction because it's we got too high cognitive load on the model. The model just cannot do it. But what we found that maybe there are other approaches. Maybe first of all, you train those separate models. There will be certain ways you can merge the model together. Then maybe it's even better than GPT-4 because the key issue is that when GPT-4 was trained, it was not trained to strengthen those two capabilities first, then merged. It's training a different way. Maybe a new way of training could actually solve the problem. But the fact is that till today, GPT-4 isn't perfect, even compared to those smaller models.
You're thinking of like merge of those two extremes.
Yeah.
So maybe like a follow-up question to that would be, do you think like it's actually the core fine tuning that's like problem here? You really got to actually go and do like a full model rebuild to get it not to hallucinate, or do you think like, because you know there are different ways you can do it. Which layer do you think you can intervene at, or is it really at the intrinsic core of the model?
That's a very, very good question. I think from a research point of view, we also really haven't completely understood that. We found that even in certain cases, it's really the pre-training bias. It's actually hurting the model. Maybe you even need to change pre-training. For that, so we are still exploring. But it's a very, very good question.
Yeah, there's three layers. It's like the core training data, the SFT, and then the human feedback layer. All three layers. I'm just curious how far you've gotten.
Yeah, so definitely we haven't really gone to the pre-training part because that takes so much money to do. But for other parts, turns out to be very important for improving the performance.